In this lesson, we're going to be looking at working with rigid transformations. So let's take a look here at comparing some transformed figures. So in this figure, segment CD is the perpendicular bisector of AB. So name a transformation that takes A to B. So if CD is the perpendicular bisector, so we got a 90-degree angle here, and AB is being split equally here. So we could just reflect A over line CD. We could translate A along the segment AB. So we could translate A just directly to B. You could even rotate A 180 degrees around point M. Any of those would work. A transformation that takes B to A, so very similar. You could reflect over CD, rotate 180 degrees, either clockwise or counterclockwise around point M, translate B to A along that segment BA. A transformation that takes C to D. So now we can't reflect over AB because these two pieces, CM and MD, aren't the same. So since M is not in the middle there, we won't be able to just reflect or even rotate around point M. We would need to find the midpoint of CD to do that. So I would say the only one you can do here is translate C to D. And then same for D to C, we would just be able to translate it unless you found the perpendicular bisector of CD. Okay, so let's go ahead and take a look at some rigid and non-rigid transformations. So if you were in class, there's a card sort. So there was a set of cards that you were given to separate in two different ways. There's also a Desmos activity posted. So if you were absent, when you go through the Desmos activity, the cards will be in there. So these are the cards. So you just needed to sort these into two different categories. So you could do that now by just writing down, if you're going to put 1 and 2 together, what else are you going to put together? And so pause the video once you've gotten one set completed. So maybe you put together cards 1 and 2, and then maybe you put together 3 and 4, and maybe you put together, 3 and 5, and maybe you put together 4 and 6. Because maybe you said these ones were triangles, these ones were quadrilaterals, and these ones had points. Maybe that was your reasoning. Then you're supposed to do it in another way. So now take a second, do it in another way. So maybe you did this one, and this one together. Maybe even this one. And then you did these two together, because when we were just talking on the other screen, we talked about rigid and non-rigid transformations. So these are rigid transformations, all these green stars, because they keep the same size. And these two go to different sizes, so they are not rigid. Again, you could have come up with other things of reasons that you connected different groups together. That's just two possibilities. So when we're talking about the different categories that you could have come up with, again, we talked about rigid transformations as a possibility, and remembering that rigid transformations are figures that are called congruent when there's a sequence of rigid transformations that takes one to another. So for instance, in this one, you have some type of rotation. So you rotated A, B, C 90 degrees clockwise, some point of rotation in here. This one looks like a translation, so you just moved it along a vector, moved H to H prime. A rotation here. Okay, whoops, that's not the right way. Some type of rotation here. Potentially looking for an angle there that would rotate them up, or sorry, a point there that would rotate them up. Okay, and a rotation here. This one also might have been a rotation and then a translation, like rotating it down and then translating it up. But it becomes a little bit harder to define rigid transformations when there isn't a grid behind them. Okay, because we can't fully see if they're exactly the same size. We can't see the exact lengths of the sides. We can't name the translations specifically of like left, right 4, up 1, okay, or where the point of rotation is exactly. So when it's not on a grid, it becomes a little bit more challenging to define and describe specifically. So let's take a look at determining whether a reflection can take one figure onto another. This is at the bottom of page 119. So we're going to take a look at the previous cards that we discussed in class and work on a single transformation that can map one to the other. So Diego says, I see that a reflection could take RSTU, this bottom trapezoid, to R prime, S prime, T prime, U prime, but I'm not sure where the line of reflection is. How could Diego see that a reflection could work without knowing where the line of reflection is? Okay, so how is he seeing that there's a reflection even though he doesn't know where the line of reflection is? And so you can see that these letters kind of flip. Okay, they flip over. Also, maybe you're noticing that if you're connecting S to S prime, R to R prime, T to T prime, U to U prime in your head, you're seeing a bunch of parallel lines. And then how could Diego find the exact line of reflection? So if he found the perpendicular bisector of any set of points, S to S prime, T to T prime, U to U prime, if he were to construct the perpendicular bisector, then he would end up with the line of reflection. So there's the two circles around S, S prime. When I connect these intersections, that's actually the line of reflection, is the same as the perpendicular bisector. Again, you could have done that on any of these, U to U prime, R to R prime, T to T prime, and gotten the line of reflection. So which triangle is the original shape here and which one is the image? Okay, so you can tell the original because it doesn't have the little primes next to it. So right here, A, B, C, this is the original. What would be a sequence of transformations that could take A, B, C onto A prime, B prime, C prime? Explain how you know the image of A coincides with A prime. So I'm just going to erase this here. So again, you have a bunch of different ways that you could come up with transformations here that would map. So maybe some type of rotation. So finding some middle point that then this is going to rotate around and figuring out that angle of rotation. So connected to the middle point. And then describing that angle of rotation. So not quite 180 degrees, wherever that point is going to be. Again, harder to say when it's not on a grid. You could also rotate this shape itself 180 degrees and then translate it. Okay, so maybe not quite 180 degrees. So let's see. So if we rotate this, let's see, this would be 90. So this is something like maybe 135. And then translate. So rotate it 180 degrees around itself. And then you could translate. So now this is point B. This is where point B moved to, and then move B to B prime. Okay, you could start with the translation first. So instead of rotating, you could start with the translation. So you could say translate A to A prime, and then you could do the rotation around A. So then you could rotate to take C to C prime around point A. So rotating around point A until you got C to C prime. But a bunch of different ways to do that. And so depending on how you describe that, if you say translate A to A prime and then rotate C to C prime, okay, that could work for multiple triangles since you're not actually putting an angle in there. You're just saying translate this letter to that letter, so A to A prime, and then rotate C to C prime. So it could work for others if there's a translation rotation in it. So what's different in this case than the previous one? So in this one, the letters kind of flip over versus here you've got that rotation of the letters. Okay, so just being turned around versus this one being flipped. So what happens when we try to do that same sequence of grabbing the shape and then rotating C onto C prime? Okay, so now it's not going to be on itself because the order of the letters changed from that flip. So in this one, we would need to add move A to A prime, rotate to C, rotate C to C prime, and then reflect over this line so that we can get B onto itself, then flip it over the line. Okay, so there's a way to describe a sequence of transformations without guessing. So if you don't have to guess, then you could be moving those. So let's go back to this one. So if we're not going to construct, okay, so let me get this stuff out. Like you could construct these, but if you didn't have your construction tools, okay, we could have said in this one even to translate R to R prime, rotate S to S prime. Let's see. Okay, rotate S to S prime, then reflect over RS, and would have landed it right back on there if we couldn't just do right over the line of reflection or have the tools to describe that. So moving, okay, you know, matching the figure, okay, telling which vertex moves to which one, so E to B, then rotate D to D prime, or you could even say F to, which one's this? Sorry. Yeah, F to, you could even say F to C and flip over BC, or you can get this to come all the way to the other side. So this picture is having D go to A so that the triangle sits on the right, on the left-hand side, and then flipping it over. So hopefully you can describe transformations that take given points to another set of points now. And then you can try this cool down. And then you can work on your lesson 17 practice problems on page 122 to 125.